In 1a, we need to expand and simplify x plus 5, x minus 9. So it's going to be x squared minus 9x plus 5x minus 45, which simplifies to x squared minus 4x minus 45. In b, we need to factorize fully 9x squared plus 6x. We notice that 3x is a common factor, so it's going to be 3x brackets 3x plus 2. In 2, we need to work out on the calculator this expression, and we get an answer of 157.668255, which correct to 4 significant figures is 157.7. In 3, we've got a scatter graph showing science and maths test results. And we are told that Jamie got a mark of 34 in the science test, and we need to use the scatter graph to find an estimate for Jamie's performance in the maths test. We start by drawing a line of best fit. Obviously, everyone will draw something similar yet not identical, and then we go from 34 up and to the left to read off a value of 39. So our answer will be 39. However, do bear in mind that the examiner is accepting here anything between 35 to 42. In 4, we've got a grouped frequency table for the time taken to run a race, and we need to work out an estimate for the mean time. We start by adding an extra column of midpoints here. So the midpoint of the 5 to 10 class is 7.5. It's 5 plus 10 over 2. Then it's 12.5, 17.5, and 22.5. So an estimate for the mean will be found by multiplying frequency by midpoints and adding them up. So plus 2 times 12.5, plus 7 times 17.5, plus 8 times 22.5, and all of it divided by the total number of people, which we have been told to be 18 students. So divide this by 18, and we get an answer of 18.6 seconds. In 5, we need to write 37 cubic centimeters in cubic millimeters. Well, we know that to go from centimeters to millimeters, we multiply by 10. So to go from cubic centimeters to cubic millimeters, we multiply by 10 cubed, and therefore 37 cubic centimeters will be 37,000 cubic millimeters. In 6, we've got Namer, who was driving to a hotel. He started off at 1:30 in the afternoon. He had to cover a distance of 65 miles, and he arrived at 14:48. We need to work out the average speed. We start by doing 13:30 up to 14:48. That's 1 hour 18 minutes. So that's the total time taken for this journey. We know that speed is distance over time. So this will be 65 miles divided by 1 and 18 out of 60 hours. And we get an answer of 50 miles per hour. In 7a, we need to write 32,460,000 in standard form. So it's going to be 3.246 times 10 to the power of 7. And then to write 4.96 times 10 to the negative 3 as an ordinary number, that's going to be 0.00496. In part C, we've got two numbers, A and B, and Asma says that 6.212 is bigger than 4.73, and therefore A must be bigger than B. Now we need to explain whether Asma is correct or not. So we've got that A is 6.212 times 10 to the 8, and B is 4.73 times 10 to the 9, and I will write this as 47.3 times 10 to the 8, so that they've got the same power of 10, and therefore I can compare the numbers here. So we see that the 47.3 is greater than the 6.212, and therefore B is bigger than A, and Asma is wrong. In 8, we've got a regular pentagon and a parallelogram, and we need to work out the size of the angle X. I will actually start by considering the sum of the interior angles of a pentagon, which can be found by doing 5 minus 2 times 180. Remember, it's n minus 2 times 180, where n is the number of sides. This turns out to be 540, and therefore each interior angle would be 540 over 5, which is 108 degrees. And therefore, going back to my diagram here, this angle here is 108 degrees. Now, in addition, I could call this angle here theta, and we know that theta must be 180 minus 117. This is because these two sides are parallel, and therefore 117 with theta are interior angles, and they add up to 180. So theta is 63 degrees. And hence we conclude that x is 108 minus 63, which turns out to be 45 degrees. In 9, we need to enlarge triangle A by a scale factor of 2.5 with center 0, 1. So it makes sense to start by drawing rays of light from the center of the enlargement passing through each of the vertices. And then we consider to go from the center of the enlargement maybe to this point here. It's 2 squares going to the right, so we can go 2 times 2.5, which is 5 squares, so 1, 2, 3, 4, 5. That would be the position of the image of the original vertex. I will do the same for this one here, so 2 to the right and 4 up will mean 5 to the right and 10 up, and therefore we get that the new vertex will be here and here. Now to go from this vertex to the one on the right is 2 units to the right, so that's going to be 5 units to the right. And then joining them together, we see that the final answer is this triangle here, which has been enlarged with a scale factor of 2.5 with center the point 0, 1. In 10a, we need to solve the given equation. I will start by cross multiplying to get that 9 plus x is 7 times 11 minus x. I will be expanding the right hand side to get 77 minus 7x, and then collect the x's on the left and the numbers on the right. So we get that 8x is 68, and therefore x is 68 over 8, which simplifies to 17 over 2. In B, we need to simplify 4y plus 3 cubed over y plus 3 squared. So the y plus 3 cubed with the y plus 3 squared simplifies, leaving a y plus 3 in the numerator. So this is 4 brackets y plus 3, which we could further expand. It's not necessary to give us 4y plus 12. In 11, we've got a tree diagram showing the probability that someone will be late for work on 2 days, and we need to calculate the probability that they will be late on exactly one of the 2 days. So they will either be late and then not late, or the opposite, so not late and then late. So I tick the scenarios I would like to happen, and I multiply the probabilities. So 0.07 times 0.98 plus 0.93 times 0.11, and this gives an answer of 0.1709. In 12, we are given a stem and leaf diagram for the heights in centimeters of 23 sunflowers, and we need to draw a box plot. Now we know that in order to draw a box plot, we need the quartiles. So to find the lower quartile Q1, I will do 23 over 4. This gives an answer of 5.75, and since this is not an integer, I round up to find the 6th observation, which happens to be 188. So Q1 is 188. I will do a similar approach for the median Q2 and the upper quartile Q3. So for Q2, I will do 23 over 2. It's 11.5. I get the 12th observation. I round up once more, which happens to be 197. And for Q3, it's going to be 3/4 of 23. This gives an answer of 17.25, and therefore it's the 18th observation, which is 209. All that remains to be done is for me to draw the box on the graph here, and also add my whiskers that will go from 173, which was the lowest value observed, up to 219, which was the highest value observed. So this is what the box plot should look like. We've got the Q1, Q2, and Q3, and then the whiskers extending from the lowest to the highest value observed. In 13, we've got two liquids, it's A and B, mixed together in the ratio of 2 to 13 by volume to make liquid C. We are being given the densities of the two liquids, and then we are filling in a cylindrical container completely with liquid C. This container has a radius of 3 cm and a height of 25 cm. We need to work out the mass of the liquid. Let's start by reminding ourselves that the density is given by mass over volume, and we will start by finding the volume of the cylindrical container. This is given by pi r squared h, and in our case r is 3 and the height is 25. So this works out to be 225 pi. I like to approach these questions by drawing up a table. So we've got A, B, C. We've got that the volume is split in the ratio of 2 to 13. So if this is 2 and this is 13, the volume of C is 15. We have actually calculated the volume of C to be 225 pi cubic centimeters, and this will allow me to find the volumes for A and B. We observe that to go from 15 to 225 pi, we multiply by 15 pi. So if I multiply 2 by 15 pi, I get 30 pi cubic centimeters. And if I multiply 13 by 15 pi, I get 195 pi cubic centimeters. We also have the densities. It's 1.21 grams per cubic centimeter for A and 1.02 grams per cubic centimeter for B. So to find the mass of A, I will be multiplying the volume by the density, because if you look at the formula here, density times volume is the mass. So 30 pi times 1.21 is the mass of A, and 195 pi times 1.02 grams is the mass of B. So to find the mass of C, which is what the question is asking for, we simply add the masses. It's 30 pi times 1.21 plus 195 pi times 1.02, and this gives an answer of 739 grams. In 14, we've got people choosing between 2 starters and 2 main courses in certain ratios here. So overall, the number of people who chose soup to the number of people who chose prawns was 2 to 3. Of those that chose soup, lasagne to curry was 5 to 3, whereas of those who chose prawns, then lasagne to curry was 1 to 5. We need to calculate what fraction chose curry. It makes sense to approach this with a tree diagram. So we've got the first option being soup or prawns, and this happened in the ratio 2 to 3. So 2/5 chose soup and 3/5 chose prawns. Of those that chose soup, so standing here, it was 5 to 3 in favor of lasagne. So it's 5/8 for lasagne and 3/8 for curry. Whereas for those that chose prawns, it was 1 to 5, so 1/6 for lasagne and 5/6 for curry. Now, those that chose curry are those that went for a soup and curry or prawns and curry, so we want to end up here or here. So 2/5 times 3/8 plus 3/5 times 5/6 will give me the fraction that chose curry. This turns out to give an answer of 13/20. In 15, we need to prove algebraically that the sum of the squares of any 2 consecutive even numbers is always a multiple of 4. So I will start by saying, for n being an integer, let's consider the expression of 2n all squared plus 2n plus 2 all squared. Well, this is exactly the sum of 2 consecutive even numbers, 2n ensures that I'm looking at an even number, and adding 2 means I'm looking at the next even number. So I will expand this 4n squared plus 4n squared plus 8n plus 4, which leads to 8n squared plus 8n plus 4. I notice that there is a common factor of 4, so it's 4 brackets 2n squared plus 2n plus 1. And since this has been expressed as 4 times an integer, then I conclude that this is indeed a multiple of 4 as required. In 16, we're told that y is inversely proportional to the square of x. So y proportional to 1 over x squared, which means that y is k over x squared. We are told that when y is 8, x is 2.5. So I'm going to use this condition to find the value of the constant of proportionality k. So 8 is k over 2.5 squared. So 8 times 2.5 squared is equal to k. So k turns out to be 50, and we've got a full relationship for y. It's 50 over x squared. Now we need to find the negative value of x when y is 8 over 9. So I will substitute y with 8 over 9. So 8 over 9 is 50 over x squared, which means that 8x squared is 450. I have cross multiplied, leading to x squared is 450 over 8, which simplifies to 225 over 4. We are looking for the negative value, so x is negative square root of 225 over 4, which turns out to be minus 15 over 2. In 17, we've got the graph of y is x squared minus 3, and we have to use this to find estimates to the solutions of the equation x squared minus 2x minus 2 is 0. So somehow I need to make use of the given graph. I start with x squared minus 2x minus 2 is 0. And we want to end up with the left-hand side being exactly what we have drawn, so x squared minus 3. We notice that what we have to do here is add 2x and then subtract 1 from both sides. So the right-hand side becomes 2x minus 1. And we notice that this is exactly what we have drawn, the y. And therefore, we need to draw the line y is 2x minus 1, and the points of intersection will be yielding the solutions. Now, to draw this, I will set 2 values for x and find the corresponding values for y to draw my line. So when x is 0, obviously y turns out to be negative 1. And when x is 3, y is 2 times 3 minus 1, which is equal to 5. So there it is. We've got 2 points, the 0, negative 1, and the 3, 5, through which the line passes. So there it is. We've drawn the line. It passes to the point 3, 5, and 0, negative 1, and we can easily identify the points of intersection here and here, and we just need to read off the values for x. We see on the left is at minus 0.75, and on the right is at 2.75. And so we conclude that x is minus 0.75 or x is 2.75. It's worth noting that the examiner is accepting from negative 0.8 up to negative 0.6 for one of the solutions, and from 2.6 up to 2.8 for the other solution. In 18, we've got a diagram showing triangle ABC with these measurements here. These the points such that the angle DAC is 2/5 of BCA, and we need to calculate the length of DC. I will actually start by calling the angle DCA to be theta, and therefore using the cosine rule, we can say that 3.4 squared is 6.2 squared plus 6.1 squared minus 2 times 6.2 times 6.1 cos of theta. This means that 2 times 6.2 times 6.1 cos theta is equal to 6.2 squared plus 6.1 squared minus 3.4 squared. Rearranging for cos theta gives me that cos theta is 6.2 squared plus 6.1 squared minus 3.4 squared all over the 2 times 6.2 times 6.1, which leads to cos theta being 6,409 over 7,564. And so theta will be shift cos of this, which turns out to give a value of 32.0804 ... Notice that I give more accuracy than the 3SF that I need to end up with. It also makes sense to go back to my diagram and update with the value of theta we just found. So 32.0804. And therefore we can now proceed into finding the angle DAC, which we have been told to be 2/5 of theta. So 2/5 of 32.0804 gives an answer of 12.8321 ... And therefore we can go back to the diagram. The angle here, DAC, is 12.83, and I can find the angle ADC by using the fact that the angles in a triangle add up to 180 degrees. So we can say that ADC is 180 minus the 32.0804 and the 12.8321, and this gives an answer of 135.087. Now that I've got the angle ADC, I can go back to the triangle here. Remember, we're trying to find DC, and I will be using the sine rule. The sine of the angle D here over 6.2 will be the sine of 12.83 over the unknown side DC, and therefore sine of 135.087 over the 6.2 is equal to sine of 12.8321 over DC. We can cross multiply to get that DC is 6.2 times the sine of 12.8321 over the sine of 135.087, and this gives an answer of 1.95 centimeters. In 19, we've got the distance traveled against the time taken for a cyclist journey, and we need to work out an estimate of the speed at 6 seconds. Well, we know that the speed in a distance time graph is given by the gradient. So at 6,10.5, we draw a tangent, which is a line that just touches upon this point. So we've drawn the line here, and we will simply find its gradient. We notice that we pass through the point here, which has coordinates 8.2, 17.5, and we also pass through the point here, which has coordinates 3, 0. So we know that the speed is the gradient, so we do y2 minus y1 over x2 minus x1, 17.5 minus 0 over 8.2 minus 3 turns out to be 3.4. Remember, this is an estimate because each one is drawing a somewhat different straight line here. The examiner is accepting anything between 3.05 to 3.7. In 20, we've got the first 5 terms of a sequence, and we need to find an expression in terms of n for the nth term of this sequence. So we see that the differences between consecutive terms is not constant. It goes from 1 to 3 to 5, so it must be a quadratic sequence having a general equation of the form un is an squared plus bn plus c. So the objective is to find the values of a, b, and c. So it makes sense to draw up a table here. We've got the first 3 terms, 1, 2, 3, and I'm gonna put the nth term here below the position. So when n is 1, this expression gives me a plus b plus c. When n is 2, we get 4a plus 2b plus c. And when n is 3, we get 9a plus 3b plus c. If I do the differences, it's 3a plus b and then 5a plus b. And then once more, the differences will give me 2a. So I could come now and put the actual value of the term. So it's minus 1, it's 0, and it's 3. From minus 1 to 0, it's plus 1. From 0 to 3, it's 3. And then from 1 to 3, it's 2. So I can compare and say that 2a is equal to 2, which means that a is 1. Then 3a plus b is equal to 1, and we have found the value of a to be 1. So 3 times 1 plus b is 1. 3 plus b is 1, which makes b negative 2. And then a plus b plus c is negative 1. But we know the value of a is 1, the value of b is negative 2. So we can see that negative 1 plus c is negative 1, which means that c is 0. This means that the nth term un is simply 1n squared minus 2n. In 21, we've got a biased coin that's been thrown 4 times, and we have been told that the probability of getting 4 heads is 16 over 81, and we need to work out the probability of getting 4 tails when the coin is thrown 4 times. Now, because this is a biased coin, I will start by saying that the probability of getting heads is p. So we know that the probability of getting 4 heads is simply p times p times p times p, which is p to the power of 4. And this has been given to be 16 over 81. So this means that p is the 4th root of 16 over 81, which is 2 over 3. So the probability of 4 tails is simply the probability of getting tails raised to the power of 4. So it's 1 minus 2 over 3 to the power of 4. So it's a third to the power of 4, which is simply 1 over 81. In 22, we need to show that this simplifies to ax, where a is an integer. So let's start by writing the expression. It's 7x minus 14 over x squared plus 4x minus 12 divided by x minus 6 over x cubed minus 36x. I will start by factorizing the first numerator into 7 brackets x minus 2. The first denominator gives me x plus 6, x minus 2, and I know that division with algebraic fractions leads to multiplication by flipping the second fraction. So it's going to be times x cubed minus 36x over x minus 6. Before proceeding, I notice that the x minus 2 cancels out. So I'm left with 7 over x plus 6 times x brackets x squared minus 36 over x minus 6. Now this means that I've got 7x. The x squared minus 36 factorizes, it's the difference of 2 squares, so it's x minus 6, x plus 6. And in the denominator, I've got x plus 6, x minus 6. We notice that the x plus 6 cancels out, and so does the x minus 6, leaving us with the final answer of 7x. In 23, we've got a sector OACB of a circle with center O. The point C is the midpoint of the arc AB, and we also have a hollow cone with vertex O, and the cone is formed by joining OA and OB. We are told that the cone has a volume of 56.8 cubic centimeters and a height of 3.6 centimeters, and we need to calculate the size of the angle AOB. I will actually start by adding the information on the cone. This is the height here, which is 3.6 centimeters, and we are looking for the radius. I will use the fact that the volume is a third pi r squared h. I know the volume is 56.8 56.8. We are looking for the radius r. We know the height is 3.6. So I can cross multiply to get 3 times 56.8 is pi r squared times 3.6, which leads to 3 times 56.8 over pi times 3.6 is equal to r squared, and therefore we can find r by taking the square root of the left hand side. So it's going to be the square root of 3 times 56.8 over pi times 3.6, and this gives a value of 3.88158 for r. So I'm going back to my diagram. R is 3.88 . So if we think about it, the circumference of the base of the cone is simply this arc here. So I have highlighted the two lengths that are equal. We also notice that the slant height of the cone is the radius of the sector here on the left. So I will use Pythagoras theorem to find L. So L squared is 3.6 squared plus 3.88 squared. So I will find L by taking the square root of the right hand side, and L turns out to be 5.294. Notice I'm using full accuracy on the calculator here. And then we know that since this part is equal to this part, and if I call this angle here theta, then the length of the arc here is simply theta over 360 times 2 pi, and the radius of this is L. And we have found L. So theta over 360 times 2 pi times 5.294 is equal to 2 pi r, with r being the 3.88. It's the circumference of the base of the cone. So we do notice that the 2 pi's cancel out, and therefore theta times 5.294 is equal to 360 times 3.88 leading to theta being 360 times 3.88 over 5.294 . So theta is 263.95, which is 264 degrees. In 24, we're looking at the parallelogram where OX is the vector A and OY is the vector B. We know that P is the point such that OP to PX is 1 to 2, and R is the point such that OR to RY is 1 to 3. So OR to RY is 1 to 3. I like to put the ratios there. We need to work out in its simplest form the ratio of ZP to ZR. So I need to find two different routes to go from Z to R, this route here. So one thing we could say is that ZR, the vector ZR, is a multiple of ZP because they all lie in the same straight line, they have the same direction. So to go from Z to P, I can go from Z to O and O to P. So what I'm doing here is I'm splitting the route along already known routes, so ZO plus OP. Now ZO is simply the same as YX because it's a parallelogram, and then OP is a third of OX because we are moving in the same direction as OX a third of the way. So YX is simply minus B plus A. So I'm replacing YX with minus B plus A, and OX is A, so plus a third A. So this leads to lambda times 4 over 3A minus B, and I expand to get 4 lambda over 3A minus lambda b. Now we did say that we should find two different ways to go from z to r. So an alternative way of going from z to r is to go from z to o and then from o to r. So I will simply write this as zr is equal to zo plus or. Zo is the same as yx, and or is a quarter of oy because it goes a quarter of the full way. So plus a quarter of oy. Now yx is minus b plus a, and a quarter of oy is a quarter of b. So this leads to a minus 3/4 of b. And since we have expressed the same vector in two different ways, we can equate terms. This is the a term here, and this is the b term here. So we can see that 4 lambda over 3 is equal to 1 if I equate the a terms, and minus lambda is minus 3 over 4. So 4 lambda is equal to 3, which means that lambda is 3 over 4, and lambda is 3 over 4. So in both cases, we've got an agreement. So this means that to go from z to r is 3/4 of going from z to p. So if this is 3, then this is 4, which means that this is 1. So we're looking for the ratio of zp to zr. Zp is 4, zr is 3. So our final answer here should be 4 to 3.